Hello guys, this is Dr. Antoine, your coach in data analysis using R tool. Today I'm going to show you how you can perform linear regression using R tool, and I will show you how you can test the assumption of linear model so as to make sure that all assumptions are met. When the assumptions of linear model are not met, that means what you are saying, what you are showing as a result are not may be biased or may not be correct. Now, before I begin with showing you how to perform regression, it is better to remind you how you can state your research questions or your objective of the study, and how you can state or formulate your hypothesis. Now, first, what is the research question when you want to use regression? The research question may be formulated as what is the impact of or what is the effect of your independent variable or independent variable. And the research objective may be to investigate or to examine or to assess the impact of your independent variable or dependent variable. For instance, when you are analyzing the impact of motivation on productivity, employee productivity, you can say that what is the impact of motivation on employee productivity in this company. Your research question, that is the research question, but the objective of the study may be as the objective of the study is to investigate or examine the impact of motivation on employee productivity in this company. The hypothesis is that the motivation has no impact on productivity, while the alternative is motivation has significant impact on employees' productivity in the company you are analyzing. That's how you can state your research question, and how you can state also your study or the objective of your study and your hypothesis. Now you are going to import our data in our R2, but before I import the data, it is better to understand what kind of the data we are working on. When I created the data, I wanted to analyze the determinant of entrepreneurship based on the model which was proposed by Regression in 1991 on the theory of planned behavior. The model is the theory of planned behavior, which is a theory which is widely used in entrepreneurship when they try to analyze the intention of becoming an entrepreneur or creating a company. Now, what is the variable here? So intention is dependent variable, intention is dependent variable, attraction, social behavior, education, barrier are our independent variable. Now we are going to analyze how those independent variables may affect or how are related to intention of becoming an entrepreneur. Okay, now as we understand our variable and the aim of the study, now my intention was to just to analyze what is the impact of attraction, social norms, behavior, education, barrier on intention. That was my aim, but I didn't get to finish the study. I corrected the data, but I missed the time to continue with publication. Okay, now I think you understand. Now, as I have indicated or explained our variable, now we are going to begin with the model. And the first command is just to import your data. This command allows us to have all numbers. That's why I just run it. Okay, now I import my data in R. Just I want to see whether our data were correctly imported in R. Well, this is the result. The result of our data. Intention as the dependent variable. Attraction, social behavior, education, and barrier are independent variable. Now, The way we can learn our model, we can use what we call backward. That means including all variables in our model, and then we will just remove alternatively variables which have no impact, those variables which do not contribute in our model. That to remove them, I will just remove first the variable which has the highest p-value. The first variable to remove in the model is the one which has the highest p-value. Okay, now let's run this model. Okay, now summary of the model. Now, as you can see, there are only two variables which are significant. That means which has impact on intention. Now we have to find in our model those variables, only those variables which have impact on dependent variable, which means intention. Now, as I told you, I'm going to remove social, because now as you can see on the p-value, this social has the greatest p-value, this one. Now I'm going to run another model which has no social. Now this model, you see, as you can see, I deleted social. There's no social here. Now let's run this model. You will see the results. Okay, now as you can see here, the variables like attraction and behavior remain significant, while education and barrier are not significant or have no impact on our dependent variable, which is intention. Now I'm going to delete this education, so because it has the greatest p-value when you compare this and this one. Okay. Now you can see that barrier is not significant. That means I'm going to remove also this variable. But there is another way of finding automatically those variables, when especially we have so many variables. Now you can see it can be a long process to delete, to remove, and so on. When you use this command, it is a way of finding automatically your variable which are significant. You can do this with library mass. Now I can execute this library, and you see how it is written. That means a linear model intention, which is our dependent variable. This is what we call killed, and this is dot killed dot. And the data, this is where I saved my variables that I'm analyzing. Now I run this model. After this model, which includes all variable, I use this one. It is the same. We can get the same result when, for instance, I apply this. For instance, this model. You see now this model has all variable. When I apply this, I can get same results. Now I just need to execute this, save like this. This one, now you see, now we have only two variables which are significant. What I'm saying is, let's show you how, when I copy this one, this command, when I copy, for instance, this, when I copy this, for instance, this one, let's show you how I do this. Let's call 1, and you see now this model, as I told you, has all variable. Now I replace this, I copy this model and I put here. Now you will see we have the same result here like this, because this model has, this one has all variables. Now let's do this, you can see, and the summary of this model, summary, step, model 1, which is this one. We see we have same result. Now, okay, now you can see that, now you can see we have same result. This command, this one, it is the same as this one, the first one, which include in the model all variables. Now I can delete it. it's keeping it. Okay. Now we can run the model which has significant values, and then we will variables, and then we will test whether the assumption of linear model are met or not. Remember, when the assumptions are not met, maybe you can find other model which can fit well your data. Okay. Now we have just seen the results that are significant. Attraction, this is the coefficient of attraction. This means the change in intention when attraction increases by 1 unit, this one. And this also is the coefficient of behavior that indicates the change in intention when the one behavior increases by 1 unit. As you can see, the effect of attraction and behavior is positive, is significant, and is positive. That means when you increase by 1 unit attraction, the intention of becoming entrepreneur or going in entrepreneurship increases also by 0.17 or 7. It's the same when you increase by 1 unit behavior control. That means the intention of becoming entrepreneur or going in entrepreneurship activities will increase by 0.5. What may be the recommendation? That means as your result, it means that the policymakers, for instance, may increase the intention to attract entrepreneurship attraction. They may also explain, for instance, the importance of becoming entrepreneurship. That entrepreneurs. That is the implication. And on behavior, for instance, you in the course design, courses that they are designing, they may insist on courses that show how you can design your business, you can analyze the business, you can manage your business, because it will increase perceived behavior of doing activities related to entrepreneurship. That is the implication of your results. Okay, and these are p-value. Okay, the null hypothesis here which is being tested is that the independent variable has no effect on dependent variable, and now as the p-value is less than 5%, that means the null hypothesis was rejected, and then we accept the alternative. And when we analyze the model accuracy, now we look on this standard errors, and we look also on this square. That means our model explained about 0.70. While that means there are other variables which may have impact on intention, which are not included in our model. That's why when you write your model, there is also what we call error term, which represents all those variables or those things which are not included in our model to explain intention, entrepreneurship intention. And when you see here, it is important because now the null hypothesis which is being tested here on this test is that our variables included in our model are not significant. But you can see now the p-value is less than 5%, significance level of 5%. That means our model, the null hypothesis of stating that our variables have no effect on independent variable is rejected. That means our model is the best. Now we are going to test the assumptions of our model. The first test is to test whether the model is linear. This is important because the model is called linear model. When it is not linear, that means it means continuing with other assumption testing. Now you see that the p-value is greater than 5%. You can accept the linearity of the model. Now I can say that the model is linear. The second assumption is to test whether the mean of residual are 0. Now as you can see, this assumption is accepted because you can see this is 0, like 0. Okay, the next assumption is to test or to check where this one or whether the variance are consistent across the full range of independent variable. You can use this library. car, and here which is okay. You can see the p-value is greater than 5%. We can use this performance also. This is an advantage of interpreting our result, because you see now here it is okay. Okay, error variance appears to be almost statistic. That's good. Let me clean this. Okay, now I will check also assumption that our residuals are normally distributed. This is the important assumption, of the most important assumption that you have to see. When this assumption is violated, the model is not correct. You need to find another way of analyzing your data. Normality of residual. You can use this. You can check graphically. You can see it just seem to be normally distributed. You can use also this histogram. Now you can see just to like normally distributed. Now you can use also this graphic. It's okay. Now you can test numerically using Shapiro test of non-residual. Now you can see the p-value is greater than 5%, and you can just say that our residuals are normally distributed. You also can use this test, this from performance package. It's okay. Now as you can see here. Now you can use also this normative tested package. Now you can see that our residuals are normally distributed. The next assumption is to test whether our residuals are independent. That is also important to see, especially when you are working with time series. It's better to see whether your residuals are independent or not, are stationary and not correlated. Okay. Now let's use this test. Now you can see it's okay. The p-value is greater than 5%. Okay. Now you can test it graphically, visually. Now it's okay because all those observations you see they are under this line, this small line. Okay, we can also test for partial correlation. It's okay because all those are under limits. Okay, performance also has the test, numerical test. Okay, now you can see the result. Okay, residual appear to be independent. Okay, it's okay. Now we need to check whether there is no connectivity in our model. That means connectivity occurs when you put together an independent variable which are highly correlated, and this may cause a problem when interpreting your data, your result, because you cannot really know which variable contributes and in the model, and the information which you can have in one variable is included in another variable. That's why this is a great assumption that you have to check before we continue with your model. As limit or as threshold. At the threshold, some indicate 5, others indicate 10. And we are going to check whether this assumption is met or not. Now we can use this library performance. Now, as you see, the result is 1.99. And for attraction and behavior, also 9.99. When you use this library car, now what we see here is the same, like the same. Now we conclude that this assumption is met. Now we can see whether there are some values which are influencing our model, what we call outliers. Now we use this assumption. Now you can see there's no outlier detected. This assumption is also accepted. Okay, we can also use this command to check globally the assumption of the model. Now as you can see here, all are acceptable. Now you can see here. And what is next is to visualize the relationship. We can use this one. As you can see, we seem to have a relationship between our independent variable, which is intention, and attraction. Also it is the same for behavior here and intention. And this command doesn't work. I got a problem with my machine. All programs were deleted when I tried to install some software. This command is ggplot. I tried to install, but it doesn't work. maybe when you install ggplot2 can run this command. Also you can, it allows you to visualize the relationship. Now, as the model or assumptions are made, what is next is to make prediction of your model. Now here you can do using two ways. You can just create a new data frame which shows the variable and its new value so as to make prediction, and you can also write directly in the prediction function the value of each variable, and you will have same results. Now, as the assumptions are made, what is next is to produce your report. What is your report or your report? Now there is a library which is called the report, which can produce automatically reports for your analysis the report. You see, now when you write a report in English, you are making it using English. Now you can just copy this and paste in your research results. Just here, this part. And also you can just analyze the effect of each variable on independent variable. This library can help you to just analyze the effect of each variable, each independent variable on dependent variable. For instance, when you are asked to show which may be the first variable, which may be the first action, or which variable can give priority when you are deciding. Now, as you can see now, the effect of attraction is greater than the effect of behavior. That means this one may get more attention than this one. Okay, thank you very much for your attention. I think this is the end of our presentation. I think this video will help you or will contribute, especially in increasing the way you perform regression analysis. If you like this video, you can share, comment, and if you have not subscribed to our channel, I invite you to subscribe, because I will show you progressively how you can perform that analysis using our tool, even though you have no knowledge in statistics. But I will try to explain you step by step how you can perform your statistical test by yourself using R. Thank you very much for your attention.